All right, what a great problem here. So we have fence, and we need to make a rectangle to fence in our crops, and we're going to put it next to some water. Okay, now we know that we have 950 meters of fence. So I guess in this case we're in another country with the meters. And you know, you could put 950 straight along the edge like this, or you could put it out 1 foot and then 1 foot here and then 948, or 2 feet and 2 feet and 946, right? But that's not really going to give you the most amount of area, right? Likewise, you could also maybe do 1 foot this way, and 949 of the feet would be going this way. So you're going to maximize this area by having your field more of a rectangle or a square shape. Okay, so they give us this diagram over here, and we don't know what these widths are. So the unknown you call x. So that amount of fence is x amount of fence, and this amount of fence is x amount of fence. And the rest of your fence, 950, is going to go here minus the 2 x's that are your widths. Now, the good thing about this problem is they've already done this for you. If this was physics, you'd probably need to come up with this, but it's math. They've already done this part for you. Now, the other thing you need to know is that the area of a rectangle is length times width. So the area inside this pen is going to be my length, which is 950 minus 2x, times your width, which is just x. Okay, and this is going to be our polynomial equation here. If I distribute through, you'll see that I get 950x minus 2x squared. And we like to put it in order. We like to put our highest exponents first. Negative 2x squared plus 950x. Okay, and if you look at this, this should look familiar to you. So we know that when we go to make our field, we're going to start with 950 right along the water, and we'd have 0. Our area would be 0. 950 times 0 is 0. And what's going to happen with a quadratic equation like this is we're going to find that we're going to have this one point up here that maximizes our area, okay, based on what our length and our width are. So this point here is going to maximize it. So the first part of our highest point, right, which we know is the vertex, the first part of the vertex tells me what this is. The second part of the vertex tells me what the maximum is. Okay, so that's really what we want, is this second part of the vertex. So we need to find the vertex. Now, if I go back to my polynomial function, and I want to find the vertex in this form, in the general form, I know that the vertex is negative b over 2a. That's the x part of my vertex. And then to find the y part, I take the function of that. I will plug in negative b over 2a. So I look above. I know that my leading coefficient is going to be my a. My next coefficient is going to be my b. And then c would be whatever's out here. And of course out there there's nothing, which is 0. So that would be my c, although I don't need it. So to find the first part of my vertex, all I need to do is negative b over 2a. So I'll do it over here, negative b over 2a, which is going to be negative, the b is 950, and the a is -2. Okay, you get your calculator ready. You know that it's going to be 950 over 2 times 2 is 4. A negative and a negative gives you a positive. So 950 over 4. Let me put that in the calculator, see what that is. 950 divided by 4 is 237.5. 237.5 meters. Now that is my x value. Okay, if I'm doing x and y, this is my x value. This is also going to be the x right here. So if they want to know the width to maximize my planting area, it is going to be 237.5. Now I can plug this in to my equation, which I made right here, to find the maximum area. But the second question is also going to ask, what is the length? So if I take that 237.5, which is my x, and I plug it in right here, I can find my length. So the length is 950 minus 237.5. I'm sorry, 950 minus 2x, and the x is 237.5. And let me use my calculator. $950 minus 475 is 475. And that is my length, 475. Now the area is length times width, so if I multiply these two numbers here, 237.5 times 475, plug them in here and here, and I will get my maximum area. So 237.5 times 475 equals 112,812.5. 112,812.5 meters squared. And guess what? If you took this x, which we found right here, I'm going to box it in gray, and you took this and you plugged it in to our area function right here, I guarantee that you will get 112,812.5. Pretty neat. Oh, why not? I'm going to do it on the bottom. So when I plug it in, negative 112,812.5 plus 950 times 237.5, 225,625, and let me put those together. 12812.5, and that's it. 112,812.5. Okay, same thing. All right. So you could do it either way. You could do length times width, or you could plug it in to find, really what we found here was the function of negative b over 2a. So we found the maximum right here.